is going to be, it's easy for you to compute the offset to whatever segment you need to kind of review, because you can just mark the time when I talk about something, and then calculate the offset into the video recording, and then you can get back to just that section. It makes it easy to find the information or the material. All right, so I'm TAC and I'm teaching this CISP 440. So you guys should know that already. Okay, and I sent out some information ahead of time, some activities that you should be doing or you have should have done prior to the class. And so we're going to review a little bit of that. I'm not going to spend time to talk about the syllabus. I'm going to make the assumption that you have read and understood the syllabus. Okay, so I don't want later on people to say that I didn't know that you do not give late points to late submissions. Yeah, it's in the syllabus. Okay, so nothing should come as a surprise. So read the syllabus ahead of time. Okay, I'm counting on all of you to have done that already, before the first class. So we're going to go to the announcement just a little bit so that, this is kind of like a reminder for myself, what to do. So here we go. All right, first thing first, this class has a prerequisite of CISP 360, which is irrelevant. Okay, and I'll talk about why it is irrelevant. And it has a prerequisite of pre-calc. Some of you may have taken pre-calc before we changed the math, 375 to 372. So anyway, any pre-calc class will count. Okay, obviously, if you have taken calculus classes already, that counts as well. Okay, so that's a prerequisite. The difficult part is this class has a co-requisite, which is CISP 430. I understand that in some other colleges, there's no such thing as a co-requisite of CISP 430, but since we are here physically on ARC, we're gonna go by the rules of ARC. So there is a co-requisite of CISP 430, which I cannot verify unless you send me a verification that you have enrolled in CISP 430 this semester. Okay? So for very few people, they have taken 430 already. They're good. Okay. If you have not taken 430 already, then you have to go to this activity, read the instructions, which I trust that you can do, and do whatever is needed in order to fulfill that requirement. So you kind of have to read the instructions. And for people who say, I don't want to read the instructions, I have some words in my head, but I don't think I should say those words. I'm just going to say this, okay? If these instructions is a little bit too much, then computer science is going to be a struggle for those people. Okay, that's the best I can put it. That's the gentlest I can put these words. Okay, so read the instructions and understand what you need to do so that you don't get dropped from the class. There is a due date for this. In other words, oh, maybe not. I forgot to put it. Nope, not yet. Okay, so I'm going to put a due date on next Monday. Okay, so by next Monday, people who have not taken CISP 430 already need to submit some kind of verification that you are currently enrolled in CISP 430. It doesn't have to be this campus. It can be a FLC, it can be, on another campus. Is that okay? All right. So before I forget, I'm gonna set the due date, so this way I don't forget. So here we go. Do, 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 do. Yep. Mm-hmm. Because these two classes are basically co-developed at on this campus, so we cover the material in more or less a lockstep, kind of format. So I will talk about, graphs, and then that class will also talk about graphs. But I talk about graph algorithms from a theoretical perspective, you know, but that class will actually implement those algorithms. That class will also talk about time complexity, but from a more pragmatic perspective. And this class will look at time complexity in a more theoretical or mathematical perspective. So it does lockstep, in certain sections of the class, and that's why, it is a co-requisite. If you have taken your 430 already, you can actually go back and look at some of the material in this class, and you ask, how can I apply what I have learned in this class in 440 to help me gain a better or more in-depth understanding of the material of what you have already learned in CISP 430. So that's why it only works in one direction but not the other. Yep. hmm You can wait a little bit. Okay. As I said, I'm making the due date on next Monday by the time this class starts. If at that time you still cannot get into the class, just show me that you're on wait list of that class. That would be sufficient for me. Yep. Because I understand that all the classes are impacted, and it may not be easy for you to get into the class like right away. But you need to show me that you have at least gotten onto the wait list. Yep. All right. So now we do have a due date. Cool. All right. So do we have any questions about the co-requisite requirement of this class, which is CISP 430? Okay. Questions? Yep. So whatever you turn in needs to have the status of you enrolled in or on wait list of that class and your name on it. I know there are several ways you can get to your class schedule, but it needs to have your name on it. You can also get a unofficial transcript, because that also shows the classes that you are enrolling this semester, and it definitely has your name on it. So with that one, you can kind of black out, all the grades of your past semester. I don't need to know that. Okay, if you don't want to show me that, that's fine. You can redact, all those, information that you don't think I need to know. I cannot. I cannot get your grade from your other classes. Okay, I can only get your grade from classes that you have taken from me, and I've never taught CISP 430. Okay, I take it back. I taught it a long time ago. It's a one semester kind of thing, and I only got the assignment like the weekend before classes started. So it was kind of a fun semester. All right, so that's our CISP 430 co-requisite requirement. I might as well talk a little bit about the math prerequisite, which is not a problem for the most part. Um, let's see, where is it? Here. Okay. This one has a due date of the 24th, but most people, because it's a prerequisite kind of thing, so that means either you have it or you don't. Okay, there's no such thing as, oh, I need to sign up for that class this semester. Okay, and most people do not have an issue with the prerequisite of a pre-calc class, so it's not going to be too much of a problem. And I'm just looking to see if there are any empty workstations because we got one person standing in the back. There are some additional chairs. You can just unfold the chair and so you can at least sit down. There you go. All right. So everything is being recorded right now. Okay. So if you ask any question, the mic is not going to pick up your voice. So don't worry. Okay. If you want to, you know, cuss or say bad words, okay, it is only going to reflect on you. Okay. It's not going to be recorded. And as appropriate, I'll relay your question into the mic also. But cuss words, I'm gonna filter that. So you can say, oh, but Tag, you're not being authentic. You're not representing me and my voice. I'm sorry, I'm not gonna do that. So cool. All right. So read the instructions. Make sure that you do everything that you need to do to stay in the class. I will take roll today in at a later point. All right. So let me go back. The first link is, oh, where's my syllabus? There we go. So here's the syllabus. Just make sure that you read it, okay, and understand it. If you have any questions about the syllabus, ask me about it, okay? You want to know what I will do in certain situations before it happens, okay? So make sure that you read the syllabus. Um, I will spend a little bit of time to talk about this little compilation of topics. It is mostly something I prepare for classes like CISP 300 or CISC 310, where people are kind of like this the first time they come to they take a college level class and so on. But it doesn't hurt to kind of revisit some of these topics. The first one and also the second to the last one are about taking notes. Okay, so why do we take notes in the class? For those of you who took 310 earlier today, don't don't say a word, don't spoil it. So why do we take notes? Yep. When you write something down, you're more likely to remember it. Yes. Okay. And there's a study of they compare typing your notes versus writing. As it turns out, they think that writing is a more effective way compared to typing. Um, I personally think it has to do with when you write. Okay, there are two ways. There are two reasons. One is you cannot possibly, okay, not, I shouldn't say that, but most people do not write as fast as they can type. Okay, most people. So that means, when you're writing your notes, you have to think about it. You really have to think about, how do I write down something as concisely as possible? So that thinking is helping you to develop all the pathway in your mind to make all the connections between the concepts. Even if you're writing, I'm not quite understanding blah 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 and how it relates to blah blah blah, you're already churning. Okay, you're starting that churning in your head, in your mind. Okay, the second thing is writing is more tactile. Okay, it involves your actually writing and is a visual and tactile kind of experience as opposed to just typing. Because most of you I know can type without looking at the keyboard, right? So the tactile portion, which is using your muscles and sensations and whatnot, is also helping to develop some additional pathway in your mind, when you are writing your notes as opposed to when you're typing your notes. Okay, I can totally understand, many of you prefer to type your notes because, it's faster. Okay, you can capture more information that way. That's fine. Okay, I'm not saying that you have to write your notes or you have to type your notes, but you need to take your notes in some way. Okay, that is important. The reason why you have to take notes is simple. Your short-term memory is very short. We are talking about tens of seconds. If I talk about something like a new term and I briefly explain that, if I do not continue on that topic to relate it to something else or give you examples or something like that, it's a one-time exposure. Your short-term memory can only retain that for about 30 seconds. For me, it's probably 15 because I have ADHD. Okay, so I know my limits. So that's why we have to write down notes. Okay, because otherwise you cannot remember. Some people say, but you record all your lectures, okay? So that means I don't have to take notes. Yes, I do record all my lectures. Everything that you see on the projector, my voice, they're all getting recorded. What about your own thoughts? Okay, one, I'm not a mind reader. That's a good thing. Two, even if I'm a mind reader, I cannot record the minds of like 40 people at the same time. Okay, so your thoughts is only you can record your own thoughts. So what kind of thoughts are we talking about? This class sucks. Tech sucks. Okay? Or you can go like, I'm not quite understanding this concept. It's okay. Okay? If you don't understand the concept that I talk about in class, you can raise your hand and you can ask me to kind of explain it in a different way. But there are some occasions where you go like, well, I don't quite understand it, but I think I can figure this out on my own. Okay? Which I think is a great thing. So but if you don't write down that question, you're going to forget. And if you forget, then there's a hole in your knowledge that you thought that you would able to fill, but you forget to fill it later on. So that's why it is also important to write down questions, things that you go like, I'm not fully understanding this. Just put a question mark on that topic so that later on after class you can kind of revisit that topic with the help of a student, with a peer, or use ChatGPT, or come to my office hour, or just spend some more time on your own to think about it. Okay, but the key is you have to remember that you have to think about it. Okay. All right, so that's note taking. Um, this one is I guess to some people it's really questionable whether I should put it here, but I'm going to put it here anyway. This one explains how I learned something that is new to me, that is considerably difficult, complex, and abstract. Okay? So you would say, but you are the professor. You're supposed to know everything about this class. Well, yes, I do. Okay? But I want to document my own learning and thinking process. Now, does that mean that you have to do it exactly the same way? No, everybody learn differently, everybody take information in differently, so you have your own way, but I'm just going to show you how I do things. Okay, if I want to describe the way that I learn and the way that I think the best way to describe it is recursive, exhaustively recursive rabbit holing. All right, so let's digest those few words. Okay, recursive, what does that mean? If I don't understand the concept, I'm going to dig a little bit deeper. In terms of your Wikipedia, that means I do a right click on the term that I don't quite understand and open a new tab on my browser on that topic. Well, that's not recursive. Recursive means if I'm reading that new tab and I encounter a word that I'm not familiar with, what do? The same thing, enhance recursion. Okay, so if I use that approach, it is not uncommon when I'm trying to learn quantum computing, which by the way is I think something that's worthwhile for you guys to consider. Okay, when I'm learning quantum computing, I have to go 6 levels deep before I get to a Wikipedia page that I go like, yep, I think I got that. Okay, that's recursive rabbit holing, okay? Because I'm just going down the rabbit hole as far as I can go until I feel comfortable and go like, okay, this I get, okay? But to do this, you need to take notes because you're going to lose track of which hole am I in and why am I even here, okay? If you have that experience, it's a good thing, because that means you are so focused on chasing down the concept that you are forgetting why you are chasing down that particular rabbit hole. All you need is you know uh, breadcrumbs to help you go back up. It's like, oh, okay, I'm here because I was trying to understand this concept, and then you continue to read that page, and if you encounter another concept that you don't know, do the same thing. Right click, go down. Okay. And it's a depth first search, not a breadth first search. Okay. So that's the way I do it. Do you have to do it the same way? Nope. The way you read this particular module is you focus on just the things in the boxes, unless you also want to learn about quantum computing. So the boxes do not really talk much about quantum computing. It is just talking about approaches of how to do things, how to think, and how to kind of take notes. So I'll give you one example. I could not find the example earlier, so let me see if I can find it this time. It is a nested bulleted list so that I can keep track of where I am, along the chain of reasoning. And I still cannot find it. Ah, okay, that happens often. Uh, I still cannot find it. Okay, I have no idea where it is, but it should be here somewhere. So anyway, this is just a documentation of my own process to learn and to think and to understand something. So take it with a grain of salt. Okay, it does. If it doesn't apply to you, it doesn't apply to you. All right, so we are moving on to this one. Computer information science as a prospect career choice. It is a kind of like an odd topic to explore in a capstone class, because for many of you, this is kind of like the last class that you have to take. But I'm going to mention it a little bit here. I have had at least one student who could not get past CISP 440. And she came to my office. She was crying. She was really, stressed out. And so I talked to her a little bit. And I told her, well, why don't you take a personality test, okay, just to find out, what your tendencies are, what your interests are, and so on and so forth. She took the test, and computer science was not really high up on the list of career choices. And it turns out, accounting was really high up on that list. And I said, well, why don't you try, accounting? Ah, that means, I have to, I'm wasting all these semester with all these classes I have taken. I'm wasting all this time. I go like, well, okay, so think about it this way. If accounting is actually a much better choice for you, continuing with the computer science, route is wasting even more time. Okay, so I'm not, you're not, you cannot undo all the classes that you have taken. They're already on your transcript. So if you ever want to get back to computer science, you can. Okay, but why don't you take accounting, for one semester and see whether that's something that you also like to do? And she did reluctantly. And then the following year, she came back to me and she said, that's her calling. She really loved accounting, and then she moved on. She graduated from here, went to Sac State, get her degree, her bachelor's degree in accounting, and then I convinced her to try to get her CPA, certification as well. That's a really good certification. So that's kind of a story. I'm not trying to discourage anyone in this class from pursuing computer science, but I just want to share a story about how someone changed her major, you know, because CISP 440 was her last class and she just could not pass 440 despite all her effort. Yep. And they have a lot of rules as well. Computer science is about the application of rules, kind of more applied math kind of perspective. But they're both, rule-driven kind of fields. Accounting has more of a numerical aspect to it, and also more interpretation. Like, what does it mean when you say, this expense, is in this category but not in that category? So we don't have to deal with interpretations of, an expense item nearly as much as accounting. But you're correct that both fields have to do with calculations, numbers, and rules. So, but it turned out to be a very good change for her. So it's kind of good. Yep. Um, and then I have this little tool here. If you have not taken a class from me recently, this is something that I did last semester. It's a Google Sheet. Okay, it has several tabs. The first tab has a link to the manual as well, so you can actually read about how to use the tool. This tab here talks about concepts. Now, this one is catered to CISP 310, or a certain portion of CISP 310. So I talked about transistors, AND gates, OR gates, NOT gates, addition, what is a single digit sum, blah 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 blah. So definitely not intended for this class. But those are the concepts, okay? Those are the notations, concepts, and symbols that I introduced in that class. Okay, so you have a list of those things. And then the next tab, allows you to specify relationships between concepts. So you can say one concept depends on another concept, okay, for in one way or another. You can talk about, one concept is a part of another concept. You can talk about, how one concept leads to another concept. It specializes to another concept. Is an instance of another concept. Even, you can use mathematical notations, as a quote unquote relationship between the concepts. It's open-ended. Okay, you can describe the relationship any way you want. You can add additional ones. You can subtract the ones that are already here. Do whatever you want. Okay. The third tab, or the fourth tab, is where the magic happens. Okay. So basically, column A and column C are the concept from the concepts tab, and then column B are the relations in the relations tab. In other words, you're now building relationship between the concepts. What is understanding? What does understand mean? So I asked that question a little bit early in my 310 class. There were a few answers like memorization. Okay, well, that's kind of one part of it. Um, so what is understanding? What does understand mean? Yep. That is correct. Okay, but the reason why you can explain something to another person is because you know how the concepts connect with each other, how they relate to each other, which is what this tab is all about. Okay, it is about connecting the concepts. Okay, But then when you look at something like this, it's like it's not even readable. Okay, how are we supposed to look at this and get a better understanding of the material that we have been studying? Well, that's why we go back to the first tab, which has the word click on it. This URL is automatically generated depending on your Google Sheet. So it changes when you make a copy of this. So you go here, right click, and I just opened a new tab, and that's why we end up with a lot of bazillion tabs here. That's what it gives you. It gives you a graph using your own words, okay, to relate the concepts. So does it fit your way of understanding and learning new material? I don't know. Okay, some people are more visual than others, and some people are not very visual, and this is not going to be very helpful. This is a resource. Okay, it is just a resource for you, so that if you think this is going to be helpful, use the resource. If you think this is not going to be helpful, forget it. Okay, it's not something that you need to consider. Okay, and if you want to use this particular resource, all you have to do is to open up the Google Sheet, go to File, and then make a copy. That's all you need to do. Make a copy in your own Google Drive, and then change all the tabs any way you want, and then the link is automatically updated to your specific Google Sheet. Okay. I personally think it is kind of cool, okay? But that's just me. I enjoy making tools. Whether it's useful or not is a whole different question. I just make the tools. All right. So, so I want to make all of these resources and topics, available, or I want to talk about all of these things ahead of time, because I think if you just say, okay, out of the entire half hour, okay, maybe 3 minutes of the half hour is something that's relevant to me. That's good. That's a win already. Okay, because I just gave you an additional tool or an additional technique to do something that you did not know before. Yes, that's mermaid in Markdown. Yes. All right. For those of you who are curious, okay, and curiosity does not just kill the cat, it can land you jobs. Okay, yeah, I'll explain that. It is a very important thing to do for us. So if you go to extensions and you go to app scripts, you can actually tell exactly how the whole thing is done. Um, it's actually as simple as it's really more simple than you think it is, or simpler than you think. So there's an HTML document, and there's also a little bit of a Google App Script, which is JavaScript essentially. That's it. That's it. Okay. So if you're curious about these things and you want to learn more about, okay, how did tech get this done? That's how I got it done. Okay. It is completely free, and you are free to enhance it. Okay. So for those of you who think, I want different kinds of dotted lines and different kind of lines, make it that way. Okay, there are many ways to extend this project. I just get it started here, but there are many ways to expand the project, so we can do more with it. All right, so curiosity is important. Someone asked Sam Altman, the CEO of OpenAI, what is the most important skill in the modern day computer science area. His answer was knowing how to ask the right question. Okay, so think about that. Okay, knowing how to ask the right question. He did not even mention anything about how to answer the right question. Okay, it is how to ask the right question. So we'll probably touch on that a little bit as we go on to talk about the topics. Hmm? I don't know whether prompt engineering will continue to be a profitable and lucrative kind of job, because as AI progresses, I think it can interpret just regular questions better than before. But if you can ask the question in a more specific way, the more thought out the question is, the better answer that you can get, right? So knowing what to ask or how to ask a question is still key. And questions are usually associated with curiosity. Okay, curious people just ask a lot of questions. Okay, most of the time they ask those questions directed to themselves. It's like, how can I answer this question? Okay, instead of asking somebody else. But curiosity is something that I cannot teach. I'm not really exactly sure how to foster curiosity, but it is important. I think in moving forward, um, actual coding is not going to be as important as a software engineer or someone in the computer science field, because AI can do a certain level of coding already. So, the moving forward, the key is, knowing how to ask a question. So we'll actually address that particular topic multiple ways in this class in multiple occasions. So we'll deal with that. All right, very good. This is the MBTI or Myers-Briggs Type Indicator Personality Assessment, which is kind of fun to do. If you wonder, what your personality is, that's kind of cool. All right, so we are moving on to what the first topic, which is also linked in the announcement. I think. Okay, I don't want to say something that I did not actually say. So in the welcome message. If you scroll down, what to do before the first class meeting? Yep, the syllabus and two additional modules that I encourage people to read prior to the lecture. So reading before the lecture is also an important thing to do because even if you cannot understand everything, it will still get your mind primed and you will also have a list of questions to ask if you have read the modules ahead of time. Okay, so that's why it is important to read ahead of the lecture. And I know this is technically the first lecture, but also technically the semester started last Saturday. So I feel okay asking you guys to read the material prior to the first actual class meeting. I don't feel guilty at all. Yes, yes. Yeah, you should take notes as you're reading. So that will get me to another thing that I want to demonstrate. You can take notes, in a much more conventional way, like using a piece of paper. All you need to do is to kind of jot down some questions. You can print out what you're supposed to read, and then just use a pen, to kind of mark up. Okay, I'm not quite sure what this means, or I think this means this, but I'm not really sure. So you can kind of mark it up with your own questions. So this way, when we cover that particular topic, and if I don't address the question automatically already, then you can just raise your hand and ask your question. Yep, that is definitely a good approach, is to use, take some kind of notes. All right, so getting back to our very first topic, which is Boolean operators. The other ones you cannot see because I did not show them. So this is a Boolean operators, which is the first actual module that we are going to use. And it is on GitHub. Look at the URL. This is on github.io, which is the a way for you to publish content using GitHub. Okay, so this is not Markdown. This is rendered Markdown already rendered into HTML. All right. So let's just say that I make a mistake somewhere in these notes here, or you're reading along. Okay. So we'll, let me just kind of do the whole thing, and then we'll talk about when there's an opportunity. I'll talk about the technique. All right, so we'll start with this. We'll start with Boolean operators, okay? Because you're already here. You have taken CISP 300, 360, 400 already, okay? So even if you're taking 430 in the same semester, you have taken quite a few classes in programming already. So nothing on this slide should be surprising to you. So we'll talk about conjunction. Conjunction is known as the English word and. This is a Boolean operator described by the following truth table. Okay, so here's the truth table. And I introduced the mathematical notation of conjunction or and right here. Okay, so let's just say that you're reading this, okay, and you go like Well, maybe tech should introduce the symbol, the little inverted V symbol before the truth table. Okay, so let's just say that that's kind of what you're thinking, and from your perspective, that's a better way to do it. Okay, so if you have a GitHub account, this is what you can do. And I think it is a possibility for some people. So you go to here, improve this page by contributing and editing. Just click on it. Since I already signed into my GitHub account, so I just go straight into the editor. If you have not signed into your GitHub account, then you will get to a page where you need to sign in to your GitHub account. So then this is all in Markdown. Okay, the document is written entirely in Markdown. If you know Markdown already, obviously it's not a problem. If you do not know Markdown, it is something that you might want to consider learning. Okay, Markdown is called Markdown because it is a simplified markup language. It is a play of the name. It is a markup language. It is called Markdown because it is a lot easier to learn compared to HTML. You go like HTML. Where's markup in HTML? The M of HTML is markup. Okay. So anyway, so you go to the section that you go like, okay, I think I can do a better job. So let's just say that you want to change it here. Okay. So you just say, okay, the mathematical symbol wedge represents conjunction. Okay, so let's just say that you want to change the document so that it's easier to read from your perspective. You want to add your own questions, your own annotation, whatever, right? So all you have to do now is to go all the way to the end. Oh, you don't have to go all the way to the end and just commit changes. Now, if you're not me, okay, then you will get the option to place a pull request so that I can incorporate your changes into my document that the whole class can see. But you can also use this as a mechanism to take notes because the copy that you have forked, okay, you're creating a duplicate of the original is yours. Nobody else can see your copy. I cannot see your copy. Nobody else can see your copy. So you can now write all the notes that you want in the original document. You can also use CSS, okay, to change the color of the font, use a different, typeface, and so on and so forth. So your note stands out compared to the original text. So that's another way to quote unquote take notes, in this class is just to use the original document. So the refresh takes a little bit of time, and it's not really an important one, so I'm okay not to actually do it. Yep, go ahead. Uh, yes, I believe so. hmm And it takes about a minute, if I do it, it takes about a minute to for the change to propagate into, what you actually see here. It was here, and I think it should be updated already. So there we go. All right. So if anyone notice any typo, spelling mistakes, or just otherwise things that you can improve, you can always use this mechanism to contribute to the material. The material is considered as OER or Open Educational Resources. So the licensing allows you to make all the changes that you want and then re-release, the updated or revised version. Okay, so it's kind of cool that way. All right, so let's take a look at the conjunction, your truth table. How do we read a truth table? So the way we read a truth table, I'm just going to pick a particular row. Let's pick this row here. So this row is basically saying if x is false, y is true, then x and y is false. That's how you read this particular truth table. If you have never been introduced to the concept of a truth table, it is a really useful concept. Okay, so I am going to refer to the concept of a truth table quite frequently in this class. Okay, it's because it's useful for many purposes. And then later on, I actually do explain the notation. So this is the C++ notation of conjunction. This is the mathematical notation of your conjunction. So if you just want to know how to type the little wedge symbol, you can always go to the mathematical notation, right click on it, go to show math as, and then go to tech command. And there we go. You can even copy and paste it. So it's an easy way to learn how to type mathematical notations inside Markdown. Okay, because it's actually a pretty useful skill set to have. If you're a computer engineer, computer engineers do not like to use ampersand ampersand because that kind of more of a C++ kind of thing. They do not like the mathematical notation because you can't type it on the keyboard. So typically they look at it as a multiplication. So conjunction is compared to multiplication from the perspective of computer engineers. So sometimes they would use a dot, sometimes they don't even use a dot. It's just like x times y, but the meaning is x conjunction y. Are we good so far? So these are all the alternative notations to express that we are looking at the conjunction between x and y. Disjunction is basically OR. Okay, this is the truth table of disjunction. The only time you get a result of false is when you have false or false. For everything else, if at least one side is true, then the result of disjunction is true. Okay, so I hope none of this is surprising to you. Okay, because after taking CISP 300, 360, and 400 at least, this should be like, yeah, I know this already. Maybe the idea of a truth table is new to you. That's okay. That's just a representation. But the concept of conjunction and disjunction should not be new to you. All right. So notations wise, in C++, we use bar bar, to represent logical OR. This is the mathematical notation, and then computer engineers typically use addition to represent, disjunction. Do we have any questions at this point about the notation or the concepts? Okay, we do not have any questions. And the last one that is negation. So negation is it looks like a little cliff symbol in mathematical notation. So not false is true and not true is false. Okay, that's basically how you read this your truth table. Notation wise, exclamation point is what we use in C++. And then in mathematical notation, we use this little cliff-like symbol. In electrical engineering, we use a bar above the equation to mean negation. And because a bar is difficult to type, so sometimes people just use a slash to mean negation, especially when you look at the pin out of a IC integrated circuit. It's a very common thing for people to use a slash to mean negation in that case. All right. Are there any questions? Yep. So in the test, because you'll be handwriting, so you can use any notation that I can understand. So you can use the mathematical notation, the computer engineering notation, which I think is the best because it's the most concise. But you're free to use any notation, even using the C++, which I think is the most verbose and unnecessarily long notation. Python just spell out the words. Yep. 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 Hmm. All right. Any other questions? All right, so we're going to move on to operators that is new to you because it's not in a programming language, but we need to use these notations in this class. So this one you can kind of ignore. I threw this in, okay, as a NAND as an operator because you can use if if a programming language needs to be as simplistic as possible using the fewest number of operators, you just need a single one, NAND or nor. Okay, either one can be the only operator. So the idea is if you need, this is the symbol of NAND, which is negated AND, and the negated AND is defined here. X NAND Y is the negated result of X and Y, and hence the name NAND. The first N stands for negated. Okay, so NAND is negated AND. So this one here says the negation of X, okay, the logical negation of X is the same thing as X NAND X. Okay, hmm, does that make sense to you? So if it doesn't make sense to you, what do? You notice that you have a question in your head, okay? So that's important, okay? Just noticing that you have a question in your mind is important because if you don't notice that question, you're not gonna be able to write down some notes. It's like, okay, I don't understand how this works, okay? So knowing how to ask the right question means, first of all, you have to know that there is a question to ask. All right, so let's say that we have this question, okay? How do we know that the negation of x is x NAND x? So now you have a choice. You can wait for me to explain it, or you can try to figure out a way to go convince yourself that that works, okay? So I'll let you guys just do a little bit when I'm setting up my tablet, because I think this is best explained when I'm using a tablet, so I can freely write, what I need to write. Okay, so here we go. Here we go. Power. Turn it on. Okay, now it works. There we go. All right. All right. So, how many people have figured out a way to convince yourself that the negation or the logical negation of x is really x NAND x? All right. A few people. Okay. Very good. So, if you're still thinking about how to do this, I'm sorry. I'm gonna spoil. Okay. I'm gonna explain the answer right away, but I will kind of reserve the next two exercises for you so that you have a chance to practice as well. All right. So we are looking at the negation of x, which we know what it does, right? Not true is false, not false is true. And I claim that it is the same as x NAND x. So the up arrow is the symbol representing NAND. You go like, I cannot think in terms of NAND. Well, that's okay, because we know what NAND does, right? Because the on the side, x NAND y is defined as the negation of x and y. Okay, we just talked about that a little bit earlier. So now you look at this and go like, oh, okay, fine. We can now expand this to be the negation of x and y, x and x. Is that working okay so far? Using the definition of NAND, we can now say, okay, so is the negation of x the same as the negation of x and x? Now, I think that should be fairly obvious now, okay? Because x and x is just x. If x is true to begin with, x and x is true. If x is false, then x and x is also false. But what if you're not even convinced of that? What do? The truth table. The truth table, which is also a way of testing it. Okay, so what you do is you just go like, okay, this is the variable x. It can be false, it can be true. And this is x and x. If x is false, x and x is also false, and that's coming from the truth table of conjunction. Okay, we just look up one row of the truth table of conjunction, and we come to the conclusion that if x is false, then x and x is going to be false. And if x is true, then x and x is also true. Okay, So this is identity. Then you have another column here and say, but what if okay, what if I were to negate x and x? Well, that means I just have to negate the result of the middle column now. So not false is true and not true is false. Okay. And then you have another column that is just the negation of x, okay, using the math symbol. And not false is true, not true is also false. Aha! Look at this column and this column. They are exactly the same. So this is how we can establish the negation of x is the same thing as x NAND x. Is that okay? I have not introduced any new tools or new way of thinking things. I'm just reusing all the things that I have already introduced a little bit earlier in the class. Yes. Um, okay, so if I were to expand this, this is in C++ notation, that. We are negating the result of the conjunction of x with itself. X is referring to the same variable. So according to the parentheses, right, we perform the conjunction first, and then we negate the result of the conjunction. There's no x negated x. Yeah, this is by this is by definition. X, okay, by definition, this is where the definition is. X NAND y is defined to be the negation of x and y. Yep. Okay. All right. You first, and then you go ahead. -1. I don't see how where the -1 is going. So negative is an arithmetic operation that does not make any sense in logic because there's no sign in Boolean values. So arithmetic negation does not really have a place in in the transition to Boolean. Okay. Hmm. The outcome of the bracket, like parentheses, is negated. I would stay off of the whole concept of -1. Okay. Yeah, one minus makes sense, but not the -1. Yep, go ahead. The first one? Oh, you mean the negation operator? You mean this one here? It's not floor. So if you want to know how to type this is \neg for negation. The floor symbol is this. This is the floor symbol. This is the floor of x, and this is the ceiling of x. Yep. So they're not the same. Yep. So I'm gonna erase the other two because it really does not It's not relevant here. Mm, that, there you go. All right. Any other questions? Looks like this has been a good discussion. Okay. So noticing that you have a question in your head that something is not adding up or something is not quite clicking is actually important. Okay, if I have a single superpower, guess what it is? I'm fairly confident to know what I do not know. Then you go like, that's a lame superpower. Okay, you're not even knowing stuff. All you know is what you do not know. But it is important when you're trying to study something and you're trying to understand something, because then I stop. It's like, oh, okay, get my shovel out. It's time to dig some holes. All right, so let's move on to to the other two. Okay, so now we have we have this thing here, which is x logical and y is the same as x NAND y, the whole thing, NAND x NAND y. Okay. Now, the actual Boolean algebra to kind of come to this result here is a little bit complicated. We haven't really talked about Boolean algebra yet. But how can you convince yourself that the right-hand side and the left-hand side are in fact the same, given everything that we have talked about so far? Exactly, the truth table. Okay, so what you do is you make a truth table. So I will give you a template of that truth table, but I will let you guys populate that truth table. Okay, because it is a little bit on the tedious side, but I will set it up for you. So we have x and we have y as independent variables. Independent means the value of y does not influence the value of x. Okay, they have no influence on each other. So that means when x is false, y can be false or true. When x is true, y can also be false or true. So there are four rows to this truth table. And then the next column is just a regular x. Was it and or? I can't remember. See, this is a good demonstration of short-term memory. I cannot even remember the context. I remember it's either and or, but I cannot remember which one. That's how short-term my short-term memory is. And I know the topics already. If you don't know the topic, you're learning something new, your short-term memory is even shorter because it's something new to you. So this is and, okay, so we have x and y, okay, populate this particular row and column. And now we have the really, really long one, which is x NAND y, NAND x NAND y. So once again, I know most of you cannot just read the NAND operator and work with it natively. I can't either, okay? You're not the only one. But that's okay. We can just translate the whole thing into a super long and complicated thing to work on it, okay? Because we have this definition up here, okay? So let me use a mouse pointer. We have this definition up here. We'll just use it, okay? We'll use it to expand, the entire expression. So now this becomes the negation of x and y, and then we have another and with the negation of x and y, and then we take this entire conjunction and negate the entire thing. That is the result of x NAND y NAND x NAND y. Okay, but now that it is in C++ notation, if you feel a little lazy and I don't want to do it by hand, write a C++ program to do it. Okay, so now the question is, are you going to end up with the same values of on every single row for all four rows? That is the question. Okay. Then you go like, this is not a real mathematical proof. Okay. If I present this to my professor and say that I have exhaustively tested every single case and they all match up, your math professor will probably cringe at you and go like, ugh, that is not a proof. It's not elegant. But in Boolean algebra, it is just as good. we are happy and accept this as a proof that the two expressions are equivalent. Not a problem. Is that okay? That's one thing that you can do with Boolean algebra that you cannot do with other kinds of algebra, which is to exhaustively test every single case. If the two columns work out to be exactly the same, that's your proof that the two expressions are indeed the same. They're equivalent to each other. Yes, I don't know enough about quantum computing to answer that question. The note that you saw earlier, that's as far as I was able to get, that particular summer in terms of understanding, quantum computing. So I cannot answer that question. Sorry about that. But this is your exercise, okay? This is your chance of using a truth table to prove a particular expression is equivalent to another expression. Okay, it is a useful exercise, because it will convince you about the value of a truth table and also how to use a truth table. And then the same thing for the next one. Okay, x or y can also be converted to x NAND x NAND y NAND y. Same thing, set up the truth table, okay, and then try to determine the value of this column, determine the value of this column, and they should be identical for all four test cases. Okay, so it's an exercise. Does that mean you have something to turn in and I'm going to grade it? No. Does it mean that you shouldn't be doing it? No, you should do it. Okay, you do it on your spare time because it will help you, understand, the application of a truth table, and I think it's a very valuable experience. All right. So moving on to the next one. Okay, this one I threw in just for fun. Okay, but from this point, don't you think that it's like, so we learned about negation, conjunction, and disjunction for nothing because all of those can be emulated by one single operator, which is called NAND. You're kind of right, okay? But for convenience, we kind of like our negation, conjunction, and disjunction operators. It just makes things look kind of nice. So as an exercise, okay, if you're taking any programming class, if you have any type of logical expression to express, try to convert all of those to only use NAND. It will be a little bit on the painful side. It can be done. It's just a little bit unnecessarily painful. Hmm? It is a regex. Yes. Yep. You're just looking for a pattern and say replace it with that pattern repeatedly until there's nothing left of the original negation, conjunction, or disjunction, and turn it in to your professor like your Iraj and see his reaction. He's like, "What is this? The tech taught us about NAND, and it's the only operator that we need." Yes. Hmm. What? Um, Depends on the implementation of the compiler. Some compilers can recognize things that can be converted into a simpler format and it would do it, and others don't. So I don't know about the back end optimizer of GCC and how far it can go. Yeah, it would have to be it has to be able to recognize that the left hand side and the right hand side are the same or there's a pattern to it. Yep. But it's not difficult from the perspective of a parser. That's pretty easy stuff for the compiler to recognize. Hmm? Yep. And you can read the generated assembly code to see whether that optimization actually happened or not. All right, very good. So now we move on to an operator that is not in a programming language. It's called implication. So this is the operator. It looks like an arrow pointing from the left to the right hand side. It means X implies Y. Okay, in English, it means X implies Y. Implication is a little tricky to explain. When I use the word and or not, you guys are so used to those being logical operators, you don't even think much about it. But implies is kind of like a really weird term as an operator. But this is how it is defined. False implies false is true. False implies true is true. True implies false is false. True implies true is also true. Okay? And that is how it is defined. Okay? There's a reason why it is defined this way, but that's the definition of implication as an operator. So this is also a good time for me to give you guys, a suggestion. Okay? You don't have to follow it. When you're taking notes and you encounter new definitions, new symbols, and stuff like that, you know, after class or even in class, stash all those definitions to one little corner of your notes because it is helpful to see all the definitions, just kind of close to each other with the proximity. So this way you can kind of relate, all those symbols, and it's easier for you to look up what does that mean again. Just look up one corner and you get the definition. Okay, so that's just such a suggestion of how to organize your notes. Um, and I see that some people are not taking notes on this topic here. I'm just noticing. I'm not suggesting anything, but you know, if, if I was a student, new to all this material, I would be taking notes. Okay, I would be writing down definitions and writing down, some, personal insight of these things. All right. So now we have this little equality here. Okay, I am claiming that x implies y is equivalent to the negation of x by itself or y. Okay, another opportunity to ask yourself, okay, that's what tech claims, but how can I verify that? How do I know tech is not lying to me and misleading me? Has tech taught us enough things so that I can independently verify the equivalence between this expression and this expression here? What do you think? Truth table. Exactly. Isn't this class going a little boring? Everything is a truth table. Yep. It's an expression. Hmm. So each one is an expression. X implies Y is an expression. Not X or Y is an expression. But this is an equation. It basically says the two sides are the same. Mhm. Yep. That's one way to do it. Because if you negate X, then these two falsehoods would become true. But since the operator is an OR, so if these two are true, then the result is guaranteed true already, right? So when X is true, then we kind of have to look at Y to determine what it is. So when X is false, then Y is what determines the result of the entire implication. So you can see that this false is over here, this true is over here, because when X is true, then not true is false, which means the entire disjunction only relies on the value of y. So you can definitely reason it out that way too. Yes. Hmm. But you can also just mechanically use a truth table to work it out, and then you can see the two columns are the same. And you go like, oh, okay. Either way is good. The the important part is you go through some steps to understand why there's an equivalence here. So you can reason it out. You can use a truth table, mechanically work it out. Either way is fine. But taking that one extra step will help you establish, it will help you better understand what is implication and to treat it just like, oh, it's just an operator. Okay. You give me the right hand side, you give me the right hand side, I give you back a certain value as a result. Is that okay? All right. So I have an example that may make things worse. Okay, that's kind of something that I do. Some of the analogies are kind of sometimes it works and sometimes it doesn't. So I have a statement here. A blue cat is sick implies tomorrow is doomsday. Okay, and to make it a little bit more interesting, let's just say that each one of you pay me $50 for some words of wisdom, and that's what I gave you for $50. I told you that a blue cat is sick implies tomorrow is doomsday. You talk to your best friend about this, and your best friend said, "Man, you just got scammed. You should ask for your money back," right? And then you come back to me and go like, "I want my $50 back. I need to buy a textbook for some other class. This class has no textbook, so you cannot use that as an excuse. So you can use another class as an excuse of I need my $50 back." So now the question is, can you get your $50 back? Well, let's look at all the four possible scenarios. So the first scenario is a blue cat is sick. It is true. Tomorrow is indeed doomsday. Okay. So you come back tomorrow, which is doomsday, and then you said, well, yesterday I saw a blue cat being sick, and today is doomsday. Do you think you get your money back? Because I gave you the statement of if a blue cat is sick, then tomorrow is doomsday. And that turned out to be exactly how things unfold. Do you think you can get the $50 back? Not that the $50 can really do you any good on doomsday, but no, you cannot get your $50 back either. Okay? So it just makes your doomsday a little bit worse than everybody else. Okay, cool. Next. So the day is tomorrow is not a doomsday, and then the day before you did not see a blue cat being sick. So now the question is, can you get your money back? The answer is no, because I never said anything about what happens when you cannot observe a blue cat being sick. That is the that's the whole thing about implication is it is a one-way street. Okay? If I say if A then B, then I have never said anything about what if A is not true. I have only said about something about if A is true, then B is certain to happen. But what if A is false? It can be anyway. Okay, B can be true, B can be false. You cannot pin me on that. Okay, so the third one is kind of the same thing. I never said anything about what if a blue cat is not sick and tomorrow turns out to be doomsday. So tomorrow comes, it's doomsday, you have to deal with all the bad stuff that's happening, and you're still thinking about your $50. You go like, well, can I get the $50 back? Because Tag, you only said that if the cat is sick, the blue cat is sick, then today is gonna be doomsday. Can I get my $50 back? No, because the statement that I gave you never said anything about what should happen if a blue cat is not sick. So you cannot get your $50 back. Wait, wait. That is true. Okay, you cannot get your money back. The last one is the only time you can get your money back. Okay, so tomorrow comes, nothing happens. Okay, it's all good. And the day before, you did observe a blue cat, being sick. That is the one time that you can come back to me and go like, Tack, where's my $50? Does that make sense to you? Okay, from a linguistic perspective. Okay. Now, for some people, the word example never makes any sense. Okay, which I understand. For those people where the word examples do not make any sense, just stick to the truth table. You'll be fine. Is that okay? Yep. hmm Well, my example is more of a kind of like a wordy example, which is not even mathematical. It's just an example of how we use the words. Um, because a implication in this case is explicitly stated using implies. So A implies B can also be said using English words as if A then B. They mean exactly the same thing. Yep. So if I where do you, so A implies B, which is the mathematical notation, means the same thing as if A then B, or you can say A implies B, and there's one more. Okay, there's one more way to say exactly the same thing, which is A is sufficient for B as opposed to necessary. Yes. Yep. But not the other way around. Not the other way around in two ways. If A is false, we don't know what's going to happen to B because we never said anything about if A is false, what's going to happen? What about B? This statement says nothing about that. Say that one more time. If A, then not B, but that's an expression. So are you talking about A being true but B being false? So if A is true but B is false, then all of these would basically end up with a false. Yep. Hmm. Well, it's not about whether we want A to be true or we want B to be true. We are questioning whether the statement A implies B is true or not. In other words, getting back to our word example, the interest is not about whether a blue cat is sick. It is not about whether tomorrow is doomsday. It is about whether the entire statement is true or not. Can you get your $50 back? So you have to think about it that way. So whatever is on the left hand side, which is A, it can be true or false. Whatever is B can also be true or false. They are independent variables. The interest of the operator is to look at the implication itself and ask, is the implication itself true or false? So from that perspective, it is an operator. It's a very awkward operator because it's not commutable. Okay, if you flip the A and the B, the result can be different. Unlike conjunction and disjunction, where it is commutable. Yeah, but this one is not commutable, which means you cannot flip the two sides, in an expression. It would give you possibly different answers. But other than that, it is just an operator. It's just like subtraction as an operator. It gives you a value. If you give it the left hand side, if you give it the right hand side, it will give you an answer, and you cannot change the operands, of the two sides. It's kind of like that. All right. So we only got about 2 minutes left. So there's not enough time to cover the rest. So the next one is called equivalence, which is also, you can see it just as an operator. But the announcement also mentions about the next module, which is about set notations. So over the weekend, that's what you need to read. Okay. You are expected to read this module over here, which is about basic set notations. Now, some of you might have some exposure to the set notations already, depending on when or where you take your classes in high school. I got exposure of set theory in high school. Some of you may not have any exposure to the concept of set notations. So that's why it is super important for those of you who have not had any exposure on set notations, to read the module and take notes over the weekend so that on Monday, when we start to talk about these topics, you already know what I'll be talking about. You already have a set of questions to ask me. And one more thing before we go, we still got a minute, so I can still sneak this into the class. I'm taking roll. Yeah, I'll be lecturing on set notations on Monday. Yes. So don't leave yet, okay? Because if you do not participate in taking role and I drop you from the class because I thought you're not here, it is not my fault, okay? Okay. I don't mean it to say in a mean way, but I do want to make sure that people participate on this one before they leave. So the passcode is implication, and I'm gonna set a due date over here to be today. All right, so today is January 22nd, and I'll give you guys until 1:30 to do it. Okay, so because this way we can move out of the classroom when you're doing this. Okay, so January 2nd. And 1:30 p.m. Save and publish. There we go. So from your end, let me show you what you should see. So from your end, it is going to be on the first topic here in the introduction. It looks like a quiz, but it's not. Okay, you click it, and then all you have to do is to type implication, all lowercase, and then hit submit and answer the question. I am in class today. True. If you answer false, I will probably still count you as in. I always have some smart people asking that question in the class. It's like, what if I click no, I'm not in class today? It is now a contradiction to itself. What are you going to do about that? Hmm? Well, if you don't even remember understand the instructions for this class, you're out of this class, man. Implication. Yeah, all lowercase. Implication. Alrighty. So I'm going to turn off the recorder. Give me a sec.